Hi everyone, I welcome you in this machine learning operations learning journey. We are trying to create some tutorial videos using which you can develop end-to-end machine learning applications. Till now, our approach used to be using this Jupyter notebook, in which we first import the data, pre-process the data, write a model, write a logic for the model, and thereafter create a model and at then save the model. So this used to be our approach for machine learning processes. But now our approach will be slightly different. We are going to adopt modular coding in a structured project design. Before I will explain why we should go with the modular coding, why we should go with the structured project design, let's have a quick revisit. What are the topics that we already covered? We had discussed how can we create a Python package in last few videos. We had discussed how can we develop the modules, how can we test our Python package, and how can we import modules. These things are going to be very important for our next project that we are going to cover. All right. So we'll bring all these concepts together to build a robust pipeline for end-to-end machine learning development and deployment. That is our prime goal. Now, question over here, why? We should go with the modularized coding. Okay, can't we use this Jupyter notebook? Is there any problem with this thing? Like, if we can write everything in Jupyter notebook, save the model, deploy it, then why we should go with the modularized coding? The reason is, with the Jupyter notebook, we face certain challenges, such as we face debugging issues. Why? Because we jumbled everything in a single file. Now, if I try to identify and fix issues in that particular code, it will be a nightmare because so many things we wrote in a single file, so many logics, data pre-processing, data handling, model building, thereafter model saving, data transformation, so many things we wrote in a single file. So if there is any single issue in that whole particular project, it will be a challenge to find out and fix it. Next challenge, we have a reusability. If I have to reuse any particular logic, for example, the missing value treatment thing, okay, I have to reuse that in some other project. I can't reuse it because I wrote the code in Jupyter notebook, right? But if I'll create a module for that, then that module can be used in any other project, isn't it? The third challenge, and it is the most important one, the collaboration. If you are working in a team, obviously multiple people are working on a same project. And if you're working using the Jupyter notebook, so it will create a lot of conflicts because many people are editing the same file, right? But if everyone is working independently on different modules, okay, so in that case the conflicts can be avoided because everyone is working independently and they are taking care of their own module, right? Like someone is taking care of data pre-processing, someone is taking care of model building, someone is taking care of defining the configuration about the file. So conflicts can be up to some extent avoided. Now question over here, how modularized coding solve all these issues, isn't it? Why we had seen, now how? See, with the modularized programming, we break the code into a smaller, independent and reusable parts called modules. Now, each module has a specific purpose which will make it easier to debug, reuse and collaborate as well as scale whenever required. For example, we'll create a configuration file for defining the configuration of or for configuring the project. Okay, so configuration file can contain the file paths, the variable definition, everything, okay, within the configuration. There will be a separate module for data pre-processing or data processing, you can say, which will take care of only the data pre-processing part and data handling part. There will be a separate module or dedicated module for the model training that will just take care of the model part and the model training part. There will be a separate module for the prediction logic. Okay, that will be a standalone module for the prediction logic. So that will just take care of the making, like whenever this module will be called, it will just use its logic to make the prediction, okay, using the model which is already saved. So this approach ensures what? Better readability, better reusability, better collaboration, and better scalability of your project. And it will, most important, it will make your project production ready, isn't it? So it's like that is very important. So like when we work on a project, it is very important that our project should be production ready, and at the production, the operation team should face least challenge to deploy it. All right. That's why these kind of process will use, which will make our project more better and easy to manage. Now question over, how are we going to use it? So I'll just show you the project structure first and then we will create our project. All right. So see, this is going to be a project structure in which loan app is what? Is our main package. Okay. Within the main package, we have few sub packages like config. We have a sub package called dataset. We have a sub package called processing, and we have a sub package called train models. Now let's try to understand these sub packages. See, the main package, that loan app, is the root folder of our project, and it will have, why am I calling it a main package? Because in the loan app I am also having init.py. So it's a root package. What is root package? What is sub package? That already we have discussed in the previously explained videos. Now config. Config is a sub package that contains a file, that will contain a file config.py. That means config.py will act as a module for centralized configuration, in which you define the here file path. Okay. Thereafter variables, all the variables that we are going to use. Thereafter hyperparameters. Okay. So these are the things that we define in the config.py, that is kind of a configuration file for us. Next, we have a data set in which we will store the data. Third, it's a processing package in which will include the data pre-processing. That means whatever the data pre-processing that we have to do, we'll just define it over here. Data pre-processing. Data pre-processing includes what? Includes handling missing values, handling outliers, handling missing values, and then outliers, or any kind of transformation. Okay, so these things basically we define within the pre-processing module. Next we have what? Some train model package. So train model will contain what? The finally trained module. Okay, when our model training is done, at the end this thing will contain the trained module or the trained model that we can reuse in the deployment phase. Version will just track the project version, the current project version. Pipeline will just defines the end-to-end training pipeline, like loading the data, pre-processing, training, and saving the models. Right. So these things will be defined in the pipeline. Thereafter, predict.py will contains the prediction logic. Training pipeline will implement the training process. Thereafter, readme.md is what? Is just the description, the project description. Requirement.txt will list all the dependencies. Okay, and setup.py will be used for creating the distribution package for the project. We'll go in detail of each of them one by one, so don't worry about it. When we'll go to these things one by one, I'll re-explain it, and then we'll go more deeper about, we'll have a deeper understanding about each of these files that we are going to use. Now, what are the benefits of this structure? The benefits are better readability, better reusability, improved collaboration, and scalability. Okay, it's like the project will be ready for deployment, and whenever we need to collaborate with anyone, we can easily collaborate, because everyone will work on a independent packages. Okay, like independent config package is independent, processing is independent, so team can work independently on their dedicated or defined or assigned package. Now we have to see the steps to follow to create the project or to set up the project. So here the very first thing we have to do, what? We have to create the main package, that will be your loan app. All right. So loan app is going to be what? Is going to be our root package. How can we say it's a root package? It should have one important file which is going to have, let's create loan app. Okay. Now it needs to have one important file called init. Now it is going to be a root package. Within the root package, what we required sub packages such as config. Next sub package required is what? Datasets. Next sub package required is what? Processing. Next sub package required is what? Trained models. Next sub package required Okay, so these are the sub packages that we work upon. Then after a few independent files that will be used for version to track the version of your project. Next we required what over here? Let's see, pipeline to define the pipeline of your project. Next we required what over here? Training pipeline to trigger the final training. Okay. Next that we required over here is what? Prediction logic, right? So just create predict dot py. Okay. Next that we required what? That's fine. Then setup dot py. So I just created few packages, one package and few sub packages within it. Okay. Like config. All right. Like processing. Okay. And train models. All right. These are the sub packages I created and few files I created. Still, I have not created few more files that I wrote over here, such as manifest and requirements. So these things I'll explain once I explain like what is the need of manifest, what is the need of requirement.txt. At that time, I'll create it. As of now, I just created the Python file and package in sub packages. In the next video, we are going to write the script for each of these files. Like we'll write the script for like config.py. We'll write the script for these things and we'll try to understand how can we club them together to for a single project. All right. So stay tuned, keep learning.